Good morning to the people. I hope you're all good on this beautiful Sunday. It's about to go down. Share the link of this video with your friend, with your classmate, and tell them it's about to go down. Let's do the memo for June exam 2022, which was written last year, and hopefully we'll be able to do the 3-hour paper within an hour. So that's the idea behind everything, that when you're writing this week or next week your maths paper one, please make sure that you conserve time. You write everything on time. When it's 1 mark, you must spend 1 minute. When it's 3 marks, spend at least 2.5 or maybe 2 minutes, so that you can be able to finish the whole paper and write everything. It's always an advice that start by writing anything or which question you understand better before you try to attempt other questions which are a bit constrict. If it's the first time, don't forget to like, subscribe, and comment so that you can know what's your view. It's so great. It's quite cold this side, but yeah, I'm super happy. I'm super excited that you can go over this memo and try to finish it within an hour. Okay, let's go. Let's go. Let's go. Let's go. Question number one. This was written last year during the subtest. I believe it's quite good practice for you guys. Let's go. Now, we can actually also say that this is a question paper, as I was saying, which was written last year in 2022 in June. Course, don't forget to read your rules, your instructions before you write, so that you can have everything under control. Let's go. Question one, solve for X. It's always like that. The structure of the paper won't change. Question one, solve for X. Question two, number patterns. Question three, number patterns. Question four, functions. Question five or question six, financial maths. Question seven, calculus. Then the last question, probability. So let's get down to the business of the day and let's look at question number one, solve for X. Now we must make sure that we collect that 25 marks easily, like then you get your marks. So for X, 1.1.1, X squared plus, let's say 1.1.1. So we are given x squared plus 2x minus 15 is equal to 0. Then they said solve for x, 3 marks. The moment you see that, don't worry about anything. Instead, just look at it and solve it. Let's go. So you can solve this using factors so that we don't waste time, or we can use a quadratic formula. But let's start by solving it. So we can see that that's 15 and that's 1 and there's 2 there. So when we multiply 5 and 3, we get 15. Then when we subtract or add these two factors, we should be able to get the value of the middle term. So this is stuff which we have done in grade 10. So don't worry about anything. So this should be negative, this should be positive. Then after that, we are good to go. Then x minus 3 is equal to 0, or x plus 5 is equal to 0. Then x will be equal to positive 3, or x is equal to negative 5. Then you live happily ever after. That's 3 marks. We only spend 30 seconds on it. Then we are going. We are moving. Oh, if you are like me, you are a slow learner like me, or you love things to be correct, you can also use x is equal to negative b plus or minus square root of b squared minus 4ac, or divide by 2a, then you get your two x values. So of course we know that this is a, this is b, this is c, so we just plug these values in this formula. Then after that we just solve it. Then you get our answer. Let's now move on to problem 1.1.2. 1.1.2. What does it say? Let's look at it. Let's look at it. So they say solve for x if 5x squared minus x is minus 9, sorry, minus 9 is equal to 0. Leave your answer correct to 2 decimal places. The moment you see the word to the nearest 2 decimal places, my sister, my brother, don't even think about many things. Don't even try to find factors. You won't find them. So you should use your quadratic formula. So let's use that quadratic formula first so that you can solve this quick. So the moment you see something in brackets, don't even think about finding factors. Use your quadratic formula. Of course, we know that this is a, this is B, this is C, okay? So we know that by our quadratic formula, it says x is equal to negative b plus or minus square root of b squared minus 4a c divided by 2a. Let's substitute negative of negative 1 plus or minus square root of negative 1 all squared minus 4ac divided all through by 2 times 5. Then we get our x value to be equal to, or x is equal to, then we use our Casio calculator. Let me take my calculator as well. Let me take my calculator. Check my calculator. Where are you? Where are you? Here is my Casio calculator. I believe that everyone has this calculator so that we can pass. You punch it in here so that you get the values. So when we punch it in here, our first x value will get 1,45, or we get x is equal to negative 1,25. Then after that, you are done. You have all the 4 marks in the back. We are rushing. We are rushing. We have something to do. Great. Now, after that, you are done and you get your full marks. Let's look at the following question. Now, we are given an inequality. Wow, this is great. Let's look into this inequality. So they've given us 1.1.3, x squared is less or equal to 3x. Great. So how can we solve this? So we know that this is an inequality. So the fact that we know that it's an inequality, we can solve this fast, and we get out of there. Of course, we know that this will be x squared minus 3x is less or equal to 0. Then we should calculate the critical values. So we say critical values, then after that we equate our inequality to be equal to 0 so that we can calculate the critical values. Of course, we can see x is a common there, so x minus 3 equal to 0. Then we have x is equal to 0. Oh, x is equal to positive 3. But we are not yet done because we understand this is an inequality. So since it's an equality, which means we should draw like a number line so that you can be able to see where is this inequality satisfied, or where can we find the solutions to this inequality. Let's plot it down. So it's going to be, of course, our a is positive, so it's something like this. Of course, 0, then we have 3. Now let's plug in any number between 0 and 3. Let's plug in 1. 1 squared is 1. 1 minus 3, of course, it's less or equal to 0 because it's going to be negative 2. Let's find a number here. Let's say 4 out of the solution, like around somewhere here. So let's say 4 there. 4 squared is 16. Minus 3 times 4, it's 12. So 16 minus 12 is positive 4. Definitely, which means our solution is not found outside here. It's found inside. It's here. Our solution is here. It's not outside. So then now we can conclude that x should be the element between, we can see this is an included, so we should also use include 0 to 3, included bracket. Then after that, we are happy. If you are happy and you know, clap your hands. Then this can also be written as 0 less or equal to x less or equal to 3 because it's in between 0 and 3. So our solution should be between 0 and 3. Now let's move on because we don't have time. We should write this in an hour. Now let's check the last question. Given a plus, which is 1.2. Let's write it down so that we don't get confused. So now we are on 1.2. Oh, there's a. Okay, so we are given a plus 64 over a is equal to 16. Then they say that in the first question, solve for the value of a. How can we do this? Is quite straightforward, guys. It's a matter of you applying what you know by this time. Let's do that. Let's do that first. Of course, we multiply all sides by a, or we can just say a plus 64 divided by a minus 16 equal to 0. Then of course the common factor will be a, then a divided by a, 1 divided by 1, a, so it's a times a is a squared plus 64 minus 16a equal to 0. Then we end up cross multiplying that, then we're having a squared minus 16a plus 64 equal to 0. Then after that, we are happy. I think we can now find factors, or we can use our quadratic formula. So in this instance, let's find factors. So if we say 8 times 8, we get 16. And if we say 8 plus 8, we get the middle term also. So of course our factors will be 8, 8. They both have to be negative. Negative 8 times negative 8, positive 64. Negative 8 plus negative 8, negative 16. Boom, we are good. So then our a minus 8 is equal to 0, or a minus 8 is also equal to 0. So a will be equal to 8, or a is equal to 8. Just like that, we are done. Let's get out of there. Let's get out of there. Hence, the moment they say hence, they mean that use the answer which you have already calculated from the above question. So they're saying that hence, solve for 2 to the x plus 2 to the power 6 minus x equal to 16. So hence solve that. So they're saying that solve using what you have already done already. Okay. So we can actually say that, let's write it down first. So this is 2 to the x plus 2 to the 6 minus x is equal to 16. Of course, now we can solve it. So you can solve it based on what you have already calculated. Okay. So we can say that this is written as 2x times plus 2 to the power 6 times 2 to the power negative x equal to 16. Okay, then we can actually say that, oh, okay, this can be written as the same as 2x 2 to the power x, sorry, plus 64 divided by 2 to the positive x is equal to 16. Do you see anything that is familiar from the question which you have solved above? Yes, we do, because we know that now when it's something like this and it's equal to 16, this is the same as 2 to the x is equal to 8, because you've calculated it already. And you can also see the structure a plus 64 over a is equal to 64. So the fact that we can see that happening there, which means we can apply that same knowledge there and solve our problem fast, quick, and we are out of there. So you can see that, oh, okay, this is quite straightforward. This is quite easy. So now we can see, or we can equate our a to be equal to 8. Then now we can, of course, 2 to the x is equal to 2 to the 3. We use our calculators, guys, to find factors. So you press 8 equal to, then you press shift, then there are these 3 dots here, then you press them out, then it will give you 2 to the power of 3. And of course, x is equal to 3. So this is you applying your laws of exponents, and you are happy after that. Now let's go. Let's move forward. Time is not on our side. Let's go. Okay. Now, without using a calculator, calculate the value of that. Guys, that one is so easy. So they've given us square root of 2 to the power 102 1002 plus 2 to the power 1006 divided by 17 times 2 to the power of 998. My eyes can't see. Okay, so here is where we are now. How can we solve this, guys? How can we solve this problem? This problem looks difficult, but it's not difficult. How can we break this question down and solve it? How can we solve this problem? So let's do it step by step so that everyone will be like, oh, okay, this is how you do it. Okay, for the future references. So we can actually see that, oh, okay, this is the same as square root of um, 2001, 2 to the power 1002 plus 2 to the power 1002 plus 4, so that you can get 106 divided by 17 times 2 to the 998. Of course, this is a square root there. Then this is the same as, of course, 2 to the power 1002 is a common factor there. That will be 1 plus 2 to the 4, or divide by 17 times 2 to the power 998. Then after that, we can see that, oh, okay, this is the same as what? Okay, then we can see that this is the same as solving. This is where everything is beautiful and everything is sweet, guys. So this is the same as 2 to the 4, okay, times 17 divide by 17. Okay, why? Because we can see that we can take this 2 here, it's multiplying, and it subtract here, then we'll be left with this. Then after that, it's still under the root, and this will be the same as square root of 2 to the power 4. Then this is the same as 2, this is the same as 4. Then you're done solving that. Let's just recap this. It was quite heavy. So of course, the first step is to be able to see that the relationship between 102 and 106 is 1002 plus 4 will give us 1006. So using that to our side or to our advantage, then we'll be able to break it down, and you can see that now we have a common factor, because this here can be written as 2 to the power 1002 times 2 to the 4, applying the laws of exponents. Then after that, you can solve it until we reach here. And of course, this one and this one are multiplying. So we can just say 1002 minus 998. Let's see. 1002 minus 998, then we get our value to be 4 there. So we can see that, oh, okay, that will be 2 to the 4. Then in the bracket 1 plus 2 to the 4, which is 17, because 2 to the power 4 it's 16. Then I have 17 there, then this 17 and this 17, they cancel out. Then you're left with 2 to the power of 4, and this can be reduced to be 2 to the 2, because you know that this is the same as 2 to the power 4 times 1 over 2. So this and this cancel, then you have 2. We're just playing around, play with our laws of exponents, then we are getting out of there. Okay, if you guys have any question, type on the comment and let's see what you guys think. Now let's do 1.4. 1.4. So for X and Y simultaneously. Wow. And it's always 6 marks. Always 6 marks. So we are given 2x minus y is equal to 2. And we are also given 1 over x minus 3y equal to 1. Of course, this is now easy. So we must make another one equation 1, another one equation 2. Okay. So how can we make that fast? Of course, this can be our equation 1. This can be our equation 2. Sorry, guys, I think you can see my screen. Yes, here we are. Then this will be our equation 2. Then we make equation 3. That will be y equal to 2x minus 2. That will be our equation number 3. Of course, then we sub 3 into our equation 2. So where we see y, we'll put 2x minus 2. That will be 1 over x minus 3, 2x minus 2 equal to 1. Of course, this will be the same as 1 over x minus 6x plus 6 is equal to 1. Then after that, of course, that should be 1 minus 6x squared plus 6x equal to x, of course, because we are multiplying all through by x. Then this will be 1 minus 6x squared plus 6x minus x is equal to 0. Then, of course, this will be negative 6x squared plus 5x plus 1 equal to 0. Then we leave us to have a positive there. That will be 6x squared minus 5x minus 1 equal to 0. Then we look for the factors. Of course, we're going to have x. We also have 6x there plus 1. Then minus 1 equal to 0. Then after that, yes, of course, from this stage, you can use your quadratic formula direct, no problem. If you can't find factors, this is always there to save. And the beauty of this is this quadratic formula, you don't have to memorize it. It's also at your formula sheet. So make use of a formula sheet and you'll be fine and ready for everything. Of course, 6x plus 1 is equal to 0, or x minus 1 is equal to 0. Then x is negative 1 over 6, or x is equal to 1. But let's solve for y now. Let's sub x equal to negative 1 over 6, or x is equal to 1 in our equation 3. Then y will be equal to 2 times negative 1 over 6 minus 2, or y will be 2 times 1 minus 2. Then, of course, we can see that, oh, okay, our y here, of course, will be 0. Then our y here should be -7/3 with our calculators. Then we are done. 25 marks, 20 minutes. It's quite good. We still have more time. As you can see, we were able to conserve time from this. It's actually 26 marks and we solved it in less than 20 minutes. Okay. Now let's look at question number 2. Let's look at question number 2. Let's take a short break. Then we can look at question number 2. I hope you guys you enjoyed your break. Let's get down to the business. Question number 2. I love it. Let's have a new pen for a different question. Let's use purple. Question number 2. What do we have there? What do we have? So on question number 2, the question says the first term of an arithmetic sequence is -1, of course. T1 is equal to -1. And the seventh term, which is T7, is equal to 55. Determine the common difference. This is easy, guys. At this point, I believe that everyone can solve this question blink at the blink of their eye. So of course T1, and this is an arithmetic sequence. Of course, we know that this will be a plus of course actually T1 is the same as a plus n minus 1, say Tn first, times d. Then now T1 will be a plus 1 minus 1 times d is equal to -1. So we can actually see that our a is equal to -1. T7 is the same as, so we substitute in this general master formula there. So this will be T7 is equal to a plus 7 minus 1 times d, and it should be equal to 50. Is it 55? No, it's 35. Then we can see that this will be a plus 60 is equal to 35. But our a is -1 plus 60 is equal to 35. Then 60 is equal to 36. By transposing that -1 to the other side, we divide by 6, we divide by 6. Then our d is equal to 6. We answer what we were asked. Following question. Determine the number of terms in the sequence if the last term of the sequence is 473. This is amazing because now we know that we should know the general term first, then we can determine the number of terms in the sequence. Let's do that first. Of course, Tn is equal to a plus n minus 1 times d. What is a? A is -1. Then what is d? Our d, we found that it's 6. Then from that, you can see that we have -1 plus 6n minus 6, of course. Then this will be 6n minus 7. This is our Tn. But they are asking us if the last term is 473, what will be our number of terms in this sequence? Of course, 473 is equal to 6n minus 7. Then that will be 473 plus 7 is equal to 6n. Then again with our calculators, 473 plus 7, that's equal to 418, equal to 6n. We divide both sides by 6, divide both sides by 6. Then our n is equal to, divide that by 6. Then we get our n to be equal to 18. Okay, so there are 80 terms in this arithmetic sequence. Sorry about that. Now let's proceed to the next question. Determine the sum of the first 40 terms in the sequence. Guys, on the formula sheet, there is also the formula of this. Of course, we are given the last term, so we can solve this in an easiest way rather than doing it in a long way. Of course, Sn is equal to n over 2 times a plus L. Of course, where a is the first term and L is the last term. Of course, we are told the last term is 473. So that should be able to solve our problems fast. But nonetheless, this now will require us to calculate the T40 terms, of course, first before we can determine everything. Okay, so looking at this perspective, the sum of 40 terms, we can use this equation or we can just use this one. Sn is equal to n over 2a plus n minus 1 times d. This is the straightforward one. S40 now will be equal to 40 divided by 2. 2 times negative 1 plus 40 minus 1 times 6 there. Then we use our calculator to get the value of the sum. So when you are using our calculator, guys, please now, by now, you must be fast and know how to use your calculator. Then my S40 is equal to 4,640. Then just like that, we are happy with our answer. So this was easy to calculate the sum of the first 40 because we know this equation. Since we know this equation made our lives so pretty easy. Now let's look at the following question. Okay, here we are. Write the nth term of the number part. Oh no, we are now on 2.2, sorry. 2.2, of course, we can see that a quadratic number pattern, which shares 75 is to 53 is to 35 is to 21. 2.2.1. Write down the fifth term of the number pattern. Okay. It's okay. We don't mind. We can write that because, of course, we already know that this is a quadratic number pattern. And since it's a quadratic number pattern, that automatically means that it has a second constant difference. So since it has a second constant difference, of course, our life already easy because now we are just calculating 1, 2, 3, 4. We're calculating the next term here. Okay, T2 minus T1, 55 minus 53 minus 75, that's negative 22. 35 minus 53, that's negative 18. 21 minus 35, that's negative 14. Let's look at the constant. Negative 18 minus 22, that's positive 4. Then negative 14 minus 18, that's positive. So the constant is positive 4. So also here we should have positive 4. So negative 14 plus 4, that should be what? Negative 14 plus 4, we are getting negative 10. Then again, for the next term, we should just add 21 plus negative 10. 21 plus negative 10, then we get 11 there. Then we can actually see that, oh, okay, the term which we are looking for, T5 is equal to 11. Okay. This is something which we are now used to. So the first thing was to be able to determine the constant term of the sequence. Then we saw that, oh, the second constant difference is 4. Then after that, we went back. But as we are going down, we are subtracting, going back, we will just add. Then we are happy after that. Let's proceed. Write down the nth term of this. Of course, this is a quadratic number pattern. By now, I believe everyone knows how to determine that. Of course, you know that Tn is equal to an squared plus bn plus c. What is a? A is equal to 2a is equal to d. Then a is equal to 4 divided by 2, which is equal to 2. Then how do we calculate the value of b? 3a plus b is equal to T2 minus T1. Okay, then after that we can actually see that, oh, okay, this is the same as 3 times 2 plus b is equal to, what is T2 minus T1? This is negative 22 here. Then we plug it in. Then b will be negative 22 minus 6. Then our value of b will be negative 2 minus 6. That's 3, 4, 5, 6, 7, 8. Negative 28. Now, how can we find our value of c? Of course, a plus b plus c is equal to T1. So what is our a? Our a is, let's check it out again. Our a is 2. Our b is negative 28. Then our T1 was 75. Of course, 2 minus 28 is negative 26. So our C will be 75 plus 26. Then C will be uh 25 plus 75, that's 100, plus that one, so it will be 101. So therefore Tn is equal to 2n squared minus 28n plus 101. So this will be our general term, or the nth term of this sequence. Now let's look at the next question. This was straightforward, this was easy. You can see maths is nice, maths is super nice. Determine the maximum value of the following number pattern: negative 15, negative 53 over 5, negative 7, negative 21 over 5. Okay. Whew. This looks hectic. Let's break it down. What are we given? We are given, this is 2.2.3. We are given negative 15, negative 53 over 5, negative 7, negative 21 over 5. Okay, that should be great. Let's now break this question down. Let's solve it down, of course, so that you can get our correct answer. So, guys, from the previous question, we were able to see that we can find the maximum number, of course. Okay, so that should be from the previous. Of course, we know that Tn is equal to 2n squared minus 28n plus 101. So the first derivative of that should be 4n minus 22 times 2 is 4, and then we have 28 there. Of course, we want the maximum value, so we can say that at maximum n is equal to, or Tn, T prime of n is equal to 0, then 4n minus 28 is equal to 0, then 4n is equal to 28, then our n will be equal to 7. Okay, but we are not yet done. They say that determine the maximum value. So the maximum value will be when n is equal to 7. So now we just substitute. So let's say maximum value will be T of 7, which is equal to 2 times 7 squared minus 28 times 7 plus 101. Then we use our calculator, of course. 2 times 7 squared minus 28 times 7 plus 101, then we get 3. So the maximum value will be 3. This was quite hectic. This is what we call a level 7 question. Needs you to think. Of course, we know the maximum according to calculus. It's where the first derivative of the prime is equal to 0. So we started by determining Tn prime, then we're able to see that that should be 2 times 2, 4n minus 28. Then at T prime, or at maximum, T prime will be equal to 0. Then we calculated the value of n. Then we get our value of n there. Then we were happy, and we are getting out of there just like that. Then we were able to find the value of n. Then we substituted the value of n in the original Tn formula so that we can get our correct answer. So in other words, those figures they gave us, those values in that sequence, they're just there to confuse us. But this is quite nice if you're able to see that you are calculating from the 2.2 main question. Let's look at question number 3. Question number 3. Consider the geometric sequence 1024. Of course, question number 3. Let's use a different pen. I love blue. Here we are. So 3.1, we are given a geometric sequence which is 1024 is to 256 is to 64. Okay, now calculate the 10th term of the sequence. Oh, great. What is this sequence? This is a geometric sequence, and we know that a geometric sequence, it has a first constant ratio, which is r, and r is equal to t2 divided by t1. So since we know that t2 divided by t1 is our constant ratio, now we also know that the general term of an geometric sequence or series is Tn is equal to a times r to the power n minus 1. Let's solve their question. Let's solve it before they get on our necks. Of course, we know that Tn is equal to A times R n minus to the power n minus 1. Where is our R? Our R is T2 divided by T1. So T2 is 256 divided by 1024. Of course, again, with our calculators, okay, then we'll see that, oh, okay, 256 divided by 1024, then we get our value to be 1 over 4. So our R is 1 over 4. So Tn is equal to A is the first term, which is 1024 times 1 over 4 n minus 1. So this is our general term. But this is what not, well, we asked the 10th term. So we say T10 will be equal to 1024 times 1 over 4 to the power 10 minus 1. Then what will be our answer there? Again, we use our calculator. 1024 times 0.25 to the power of 9. Then we get our answer to be 1 over 256. This was easy. After that, boom, you're done. Just like that, you are happy. Let's look at the following question. I hope you guys are also enjoying as I am enjoying. We are given that, and it's in the sigma notation. That's scary. So 3.1.2, we are given the sigma notation, which is from p equal to 0 to 8 of 256, 4 to the power of 1 minus p. Then they say that calculate that sigma. Of course, guys, by now I now believe that you guys understand how to solve this fast, okay? So Sam is showing that this is like a series or like a geometric series. Of course, this will be when p is equal to 0 there. That will be 256 times 4. Let's see. Then we get 1024 plus when p is equal to 1, that will be 1 minus 1 is equal to 0, 4 to the power 0. Then we can see that that should be 256 when p is, so this p here is showing the starting point. So in order for us to determine the series which we'll be dealing with, we should start from 0 and go forward. So now we are at 0, then that was 1024. At 1, that's 256. Now at 2, that will be 1 minus 2, that's negative 1. So 1024, sorry, that's 256 multiplied by 4 to the power negative 1. Then we get 64 there. Okay, then after that, yeah, we can leave it there because already it's already a lot. Of course, they want to know the sum, because for the fact that they are giving us this as a sigma notation, a sigma represents sum, so that will be Sn, and we know that this is a geometric series, so this will be a 1 minus r to the power n divided by 1 minus r. Of course, a is the first term, and we also know that from 0 to 8 there are 9 terms. Okay, from 0, so it will be 0 1 2 3 4 5 6 7 8. So we have 9 terms, so we should calculate some of the first 9 terms. That would be 1024, then 1 minus 1 over 4 to the power n divided by 1 minus 1 over 4. Again, we use our calculator. We use mine. Then we can see that sum of 9 terms is 1365,33. Okay, because they say that yes, so also in the instruction they say that correct to 2 decimal places, so that's why our answer is like this. We can proceed now. Let's proceed. Of course, the first 2 terms of the geometric sequence are, okay, determine the values of t for which these converge. Why are they giving us these big numbers? So they are only telling us that the first 2 terms of all of this is negative t squared minus 60 minus 9. And the second one, it's t cubed plus 9t squared plus 27t plus 27 divided by 2. So these are the first term. So of course, how can we solve this? Of course, let's break this one first. So this is the same as negative t squared minus 16 minus 9. Then of course, that will be 1 over 2. Looking at the perspective of solving this from calculus, we now know that this will be t plus 3. Sorry, I thought you guys were seeing my screen. Yes, here we are. That will be t plus 3. Then we'll be left with t squared plus 60 plus 9. Okay. Then, of course, we know that from this side, this is the same as negative t plus 3 squared. Which is the same as t plus 3 cubed. Now, we know that r is t2 divided by t1. So our t2 is 1 over 2 t. Let's write it like this so that it can be sweet. T plus 3 cubed divided by, or this is divided by 2, divided by negative of t plus 3 squared. Of course, then we can see that our answer there will be negative t plus 3 divided by 2, because squared and cube, they cancel. Then, of course, for conversion, we know that it should be negative 1 less than r less than positive 1. So that should be negative 1 less than negative t plus 3 less than 1. Of course, cross multiply that, negative 2 less than negative t plus 3 less than 2. Then negative 2 minus 3, that's negative 5 less than negative t less than negative 1. Then we divide all through by negative there. Then we have 5 greater than t greater than 1. Of course, because we know that this is the beauty of everything, we should be able to solve this, because if we don't, it's going to give us problems. Okay, so now we can see that this is the same as 5 greater than t greater than 1. Okay, then after that we live happily ever after. Any question, guys? Let's see if I did a mistake. Yes, I think I did. I'm sorry about that. So this is negative here. Of course, these were brackets. I forgot the brackets. Sorry, guys. Then this will be negative 3, of course. Then this will be negative 1 less than negative t less than 5. Okay. Now divide all through by negative. That should be positive 1 greater than t greater than negative 5. For this is the same as negative 5 less than t less than 1. Okay. You can write this in a correct way. Okay. Then we are happy after that. This one was quite hard. So the first thing was able to break this thing and solve it, and understanding that this is a geometric sequence. So from that we can solve it, and we know that for convergence, our value of r, or our constant ratio, should be between -1 and +1. Now let's look at question number 4. Ooh, these are functions. Functions. Okay, let's look at functions. The graph of g of x is equal to a. This is different question, different pen. Let's use this one. No, let's use this one. Question 4. Okay, we are given g of x, which is equal to a 1 over 3 to the power x plus 7, and this passes through that point. Calculate the value of a. Of course, this was said it passes through e -2 is to 10. Now, calculate the value of AR. This is easy. We will substitute the value of the point E in our original equation. Let's take a short break whilst you guys are doing it. Then we'll come back within a minute. We are back. Yeah, let's fix that. Yes, we are back now. I hope you guys have solved it. Of course, this is the same as y equal to a 1 over 3 to the power x plus 7. Then we substitute point E, which is negative 2 is to 10. Then after that, we can live happily ever after, because this will be 10 equal to a 1 over 3 to the power negative 2 plus 7. Then that should be um, 10 minus 7, that's 3. Then this should be 9a, of course. This should be 9a. Let's put this in the charger. Here we go. Here we go. Yes, thank you. Then now we solve for 8 divided by 9 divided by 9, of course. Then now a will be equal to 1 or 3. Just like that, we are happy. I am happy when you are happy. So this was straightforward. We're just supposed to substitute that point E in the equation. Calculate the coordinates of the y-intercept of G. Jeez, by now we all know that the y-intercept, we let x to be equal to 0. So we write it down. Y-intercept, we should let x to be equal to 0. So let's go. When x is equal to 0, of course, our original y is y equal to 1 over 3. 1 over 3 to the x plus 7. Now x, we want y-intercept, so we let x to be 0. So y is equal to 1 over 3. 1 over 3 to the 0 plus 7. Of course, this will be 1. Then we use our calculator. 1 over 3 plus 7. 1 over 3 plus 7. That's 22 over 3. Why do I sense that we should plot this graph at the earlier stage? Let's just proceed. It's fine. This is straightforward. Y-intercept relate y to be 0. Now let's go. Now consider h of x. Oh, okay. It's a different platform now. So on 4.3, consider h of x to be 1 over 3 to the power x. Okay. Describe the transformation from G to H. So from G to H, so that was our G, and our G was A, or it was 1 over 3 times 1 over 3 to the power x plus 7. How can we describe our transformation from G of x to h of x? So guys, this is easy, because I believe now everyone understand that when we're talking about transformation or the translation, we are speaking about things going to the left up, 1 unit up, 1 unit down, to the right, to the left, and stuff like that. So we can actually see that this is a translation by 1 unit to the right, okay, and 7 units upwards, downwards, sorry. Okay, then after that, we are happy. So this was straightforward. This was easy. Now they say determine h inverse. Of course, we are given, so it's 4.3.2. H of x is equal to 1 over 3 to the power x. This is the same as y equal to 1 over 3 to the power of x, of course. Yes, now from this point we can see that, of course, when we are finding the inverse of inverse function, we swap x and y, then we solve for y, then that will be log of 1 over 3 times x is equal to y. This is straightforward, so this will be our, therefore h inverse of x will be log base 1 over 3 times x. Just like that, we solved our inverse function. Okay, let's proceed, guys. Let's make maths fun and interesting. Question number 5. Consider g of x to be that. I love it. I already see that's a hyperbolic function. So on question number 5, we can see that, oh, that's a hyperbola. So we are given g of x to be equal to a over x plus p plus q. Okay, sounds interesting. The following information of G is given: the domain x element of real numbers, where x is not equal to -2. Then we're also given that the y-intercept is at k. Sorry, the y-intercept first is at k equal to 1:0. Okay, of course. Then the y-intercept is n is always -1/2. Show that the equation of G is given by that. Oh, guys, this is sweet. So we know that. Let's analyze this first. See if this one is proper. So we know that in order for us to determine the domain of this certain function, the domain of this is always x is not equal to -p. -p is coming from here. So x plus p equal to 0. So x will be equal to -p. This is our vertical asymptote. And this is our horizontal asymptote. So this is what's important. So they are telling us x is the element of real numbers where x is not equal to -2. So which means p should be equal to +2 there. Okay, because this is what we are saying, that the domain is always on the denominator and it's always the vertical asymptote. So we already know that y is equal to a over x plus 2 plus q. Now they gave us the x-intercept, and we know that x-intercept, we let y equal to 0. Then we can see 0 is equal to a over x plus 2 plus q. Then negative q is equal to a over x plus 2. Can make that equation 1. Then, of course, at y-intercept, we are given 0 to -1. So we let y-intercept, we let x to be 0. That will be y equal to a over 0 plus 2 plus q. What is our y? Our y, it's -1/2 here. So it will be -1/2 equal to 1/2 a plus q. Then we can say 1/2 plus, sorry, that will be minus 1/2 a is equal to q. Then we can make it equation 2. Then if we substitute, uh, 2 sub 2 into 1. So where we see q, we put this. So there is negative there. Then we have -1/2 minus 1/2 a, which is equal to a over, what was our x here? Our x was 1, eh? Let's see, because the x-intercept we were given to be at 1:0. So here we're supposed to put 1 here. So this will be 1 plus 2, which means it's negative q is equal to a over 3. Okay, that will be our equation 1 there. Okay, so now we equate this to a over 3. Okay, this will be positive 1/2 plus 1/2 a is equal to 1/3 a. Then 1/2 is sorry, 1/2, 1/3 minus 1/2. Where's my calculator? 1/3, 1/3 minus 1/2. We get -1/6. Then now 1/2 divided by answer. Then we get our a to be -3. Then we get our a to be, this will be -1/6a. Then we divide both sides. Then our a is -3. Then what is our q? We just substitute there. So of course our q will be, yeah, we substitute here the a value. So this will be -1/2 minus 1/2 times -3. Then our q will be equal to 1 when we substitute there. So then therefore we can see that g of x is equal to -3 over x plus 2 plus 1. Just like that, we are happy and we've already solved that question there. Let's proceed to the next question. Write down the range of G. Oh, the range, of course, y is the element of real numbers where y is not equal to +1. Of course, it can never be equal to the asymptote, okay? And we know that q is the value of asymptote, and we calculated that, and our q was +1. Wow, functions are so nice, super nice. Okay, determine the equation of H, the x of symmetry of G in the form of that, which means the positive gradient. This is easy, so we're just taking this part here, okay? This is straightforward because we know that the x of symmetry of a hyperbola is taken here, where I just circled. So when it's a positive gradient, which means that x plus 2 plus 1 is our positive gradient, so y is x plus 3. If they said where m is less than 0, which is negative gradient, this was going to be y equal to negative x plus 2 plus 1, then it's negative x minus 2 plus 1, then x, so then y is equal to negative x minus 1. So this is for negative gradient, this is for positive gradient, but this is what they have asked us first, so this should be easy for you guys. Then the last question there, write down the coordinates of k inverse the image of k reflected over G. That's easy because already we know that 5.4, our k inverse will be negative 3 over is to 4, because they told us the coordinates of k prime is the image of k reflected over H. So after that, you can see that, oh, okay, this is easy. Sort of like it's an image. It has been reflected along the line y equal to x plus 3. So this is easy. This is straightforward for us, and we can solve this easily. So of course, y for the x value, we let y be equal to 0, then we get our answer there to be 0, then our x will be negative 3, then of course y is still the same and y is equal to 4. Sorry. Now let's proceed. So we can see that these functions, I've already covered two questions. This is a parabola. We can do it next time. Let's do the last question, which is calculus. Question 8. Question number 8. Determine f prime of x from the first principles. Oh, first principles. We are using the long method. So we are given f of x to be equal to negative x squared. So we know that when they say by first principles, this is quite easy and straightforward, because we know that we should use f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. But now, firstly, we should be able to determine f of x plus h. So f of x plus h should be negative of x plus h squared, which is negative of x squared plus 2hx plus h squared. Then we divide that to be negative x squared minus 2hx minus h squared. Then f prime of x is, of course, the limit as h approaches to 0 of negative x squared minus 2hx minus h squared minus, what was our f of x? Our f of x was negative x squared, so that would be plus x squared divided by h. Then this and this cancel. Then now we have the limit as h approaches to 0 of negative 2hx minus h squared divided by h. Then again, the limit as h approaches 0 of h is the common factor there. Then we have negative 2x minus h divided by h. This and this cancel. Then now we are left with the limit as h approaches 0 of negative 2x minus h. Of course, we place that 0 there, then it will be negative 2x minus 0, which is the same as negative 2x. So at the moment they say by first principles, which means you must start by looking for f of x plus h. Then we solve it step by step. Then we will always be happy. Great. Now let's look at 8.2. Determine f prime of f. It's given that out. That's already easy, because now we are no longer using first principles. We are just using what we call the power rule. So on 8.2.1, we are given f of x is equal to 4x cubed minus 5x squared. Okay. So seeing what we are given, and they want us to determine that first. Of course, f prime, by applying the power rule, that should be f in prime of x. That should be 3 times 4, it's 12. x squared minus 10x. Then 8.2.2 dx of negative 6 square root of x3 plus 2 divided by x4. This is easy, guys. Let's remove that bracket first. So dx will be negative 6 x 1 over 3 plus 2 divided by x to the 4. Okay. Then from that, of course, we can see that dx will be, we take x4, we divide that by x4. So this should be negative 6x, then 1 over 3 minus 4, that should be negative 11 over 3 plus 2x the negative. So we break this thing into 2 to be negative 6x 1 over 3 divided by x to the power 4 plus 2 over x to the power 4. So we make it that easy and straightforward. Then we break it down. Okay, then now we can apply it and apply our rules. Negative 11 over 3 times negative 6. That should be 22x to the power negative 14 over 3 minus 8x to the power negative 5. Then we got the answer there. So yes, guys, you can see that we're able to solve a lot of stuff within an hour. Then we are only left with the last questions. Of course, guys, we'll stream and do those last questions some other time. And yeah, it was so nice, guys, to be with you and to solve these problems with you. I hope you enjoyed solving with us. Tell us which other question or question paper do you want us to do. Without wasting much time, have a great a great day ahead and enjoy everything which you'll be doing. Please practice. If you are not on the WhatsApp group, please make sure that you join using the description of this video and whew, subscribe. Have a great evening. Thank you so much.